Hello, I'm Ed Scollon, a research associate for Lake Champlain Maritime Museum in Vergennes, Vermont. Today I'll be presenting the American Revolution Underwater, Methodologies for Mapping Battlefields in Lake Champlain. From its inception, a main focus of the museum has been the research, study, and interpretation of the engagements between American and British forces upon the lake during the Revolutionary War. Most notable was the 1776 Battle of Valcour Island. But the Battle of Valcour Island was actually a moving engagement. The engagement began at Valcour, but it didn't end until 3 days later in a bay that is now known as Arnold's Bay. Physical evidence of those heavy engagements lay strewn across the lake floor, from Valcour to Arnold's Bay, and many points in between. Those remnants have been subjected to environmental and human disturbance ever since. Among many of the museum's efforts to locate, document, and interpret what remains, we have committed considerable time and resources to the Valcour Bay Research Project, an extensive archaeological survey of the submerged battlefield at Valcour Island. Our Valcour Survey is a unique integration of the disciplines of submerged cultural resource management and battlefield archaeology. We developed a survey methodology that mitigated many of the challenges that are inherent in working in an underwater environment and optimized our ability to systematically survey a vast area of submerged terrain, as well as developing methods for documenting and studying what we encountered there. At the start of the Valcour Survey in 1999, archaeological use of metal detectors was still emerging. Now, especially with battlefield archaeology, it's become an accepted and invaluable tool. With both the Valcour and Arnold Bay surveys, our tool of choice was and remains the J.W. Fisher's Pulsate X metal detector. The Pulsate X is designed for rigorous underwater use and is waterproof to depths of 250 feet. As its name implies, the Pulsate X employs pulse induction technology. As opposed to very low frequency metal detection, pulse induction offers much deeper penetration of the terrain sediments. It's especially useful at Valcour, where those sediments extend to several feet of depth. The Valcour survey began as a response to the discovery of a fragmented cannon buried deep within the lake bed. Not only had the bay's sediment protected that artifact by concealing it from view, the anaerobic environment had left it nearly perfectly preserved. It was during our initial excavations of that artifact that we found the bay sediments offered an additional benefit. Of all conditions encountered while conducting underwater surveys, limited visibility is one of the greatest challenges. Neither the Valcour or Arnold's Bay sites are of a depth where ambient light ever becomes much of an issue. However, because of their silty bottomlands, any disturbance of that silt can cause it to become suspended in the water column. Visibility can be reduced to inches in a matter of seconds. In those conditions, it's very easy for divers to become disoriented as to their location, their direction, and their depth. Despite that challenge, we also found that we could use the lake bed sediments to our advantage. While excavating the cannon, we discovered that the clay was of a consistency that we can embed and deploy a system of PVC posts. Those posts could be marked with positional information, deployed in a system aligned with magnetic north, and used as a means for divers to navigate about the site by compass. They would prove to be especially helpful during times of silting, with excavation, or when visibility was reduced due to natural causes. We could also use those same posts to form the corners of survey grids, use them as anchors for tape measures, and employ them to investigate the area surrounding the cannon site. It wasn't long before we found the cannon was fragmented. It had accidentally burst during the engagement. Our investigation of the surrounding area uncovered a number of associated artifacts. They were composed of a wide range of materials and found to be in remarkable states of preservation. We realized that many more remnants from the battle may still lay hidden, protected, and undisturbed. We found we had a rare opportunity, and our survey continued in an effort to investigate more of the American line of battle. We developed a system of 50-foot grids deployed in a manner to optimize our underwater orientation and our visibility. A 50-foot grid may appear to be a daunting area to survey, but in conducting our underwater investigations, Maintaining neutral buoyancy in a position above the bay floor is essential to maintaining our visibility. Long transects of survey reduce the number of times that the divers have to change direction. This makes it easier for them to stay on a level plane, maintain their buoyancy, and keep them from inadvertently making contact with the bottom. The corner posts of each of our 50-foot grids would remain in their original positions throughout the course of the survey, as navigational guides across the site. During active survey, tape measures would be strung along the north and south sides of each grid. Offensive half-inch PVC posts would then be embedded at 3-foot intervals along both sides. A third tape measure would then be strung between corresponding posts in a north-south orientation. It provided a visual transect for the divers to follow. The 3-foot spacing was made when finding a surveying diver could easily swing the coil of the metal detector 2 feet laterally to each side of their transect. This spacing provides for a 1-foot overlap between transects and ensures thorough coverage. Tasks were split between a team of 2 divers, one dedicated to conducting the metal detection survey, and the other dedicated to recording their efforts and the locational information of any metallic anomalies that they encountered. The placement of these posts allowed the survey to progress without interruption, and the targets could be investigated later when currents and available personnel were at an optimum. We were excited to finally apply what we had learned from all those years of working at Valcour to our submerged survey of Arnold's Bay in 2021. We were even more excited about the potential to coordinate our efforts with those of the AMDA, the Advanced Metal Detecting for the Archaeologists Group. A terrestrial survey class had been scheduled at Arnold's Bay in October. Directing our work to facilitate the success of their survey became one of our greatest goals. Determining the location of the Galley Congress was the best place for us to start in our submerged survey of Arnold's Bay. Of the 5 original wrecks, it's the last that's known to remain in the bay. The wreck of the Congress is under the protection of the U.S. Navy. Any excavation of the wreck is under the direction and the control of their Naval Historical Center. We had yet to obtain permits to excavate the Congress. Locating the wreck wasn't only crucial to ensuring we didn't inadvertently impact her remains, but to determining how best to direct our survey. Using positional notes from former surveys and interviewing a member of a prior excavation, we located the forward section of the Congress relatively quickly. General Arnold's objective of running the Congress into the bay was to run her aground and destroy her. With a draft of a little over 6 feet, that's about where we found her. We found the tips of frames indicating that the bow was pointing towards the north shore. A large pile of ballast stones were located aft and to the south. Knowing that her stern had been separated from the rest of the hull in the late 1800s and pulled on shore, our first efforts were to try to determine the aftmost footprint of the wreck, without impacting the site. In 2020, we had interviewed Bill Liege, one of 3 researchers who had excavated the Congress in the early 1960s. Liege had recounted emptying the hull of its ballast. We decided to lay out a transect after the ballast pile. Our initial hopes and inclinations had been to employ the methodology that we'd employed at Valcour. It was here that we began to find that our methodology would have to deviate from what we had used there. The bay opens to the northwest, and from where it's exposed to the predominant winds. With over 4 miles of fetch from the aptly named Northwest Bay, these waves build considerably as they reach the shallower waters along the Vermont shoreline. These waves greatly erode the shale bluffs at the bay's mouth. There's an interplay between the sediments that wash into the bay from a stream at its deepest point, and the waves that wash in this eroded shale. These photos show how this stone is washed over one of the points at the mouth of the bay when the lake is at its highest levels. It's the same material that we find washed deep into the bay. Besides a bottom that consists of heavy clay, there is also the presence of a significant amount of this stone. The result is a stratification, which in many ways resembles a loose concrete before it's had a chance to fully cure. We found it next to impossible to embed any sort of post or anchor into the lake bed here. Instead, we used concrete blocks to anchor our transects and recorded their placement with GPS. Since we also encountered a moderate level of seaweed, we employed a rope line as our visual transect. It enabled us to pull the line taut and ensure that it wasn't bowed by obstructing vegetation. A tape measure was then deployed alongside to record the locations of any metallic anomalies that we encountered along the way. Over the course of a few days, we ran our survey along this transect, and we discovered a number of small 18th century artifacts. We also encountered timbers of the wreck, which were located beyond the ballast pile. Being uncertain as to whether some remained intact with the hull of the Congress or were disarticulated structure, we postponed any further survey along that transect. We'll return when permits are in place for further excavation. By now, we also had a much better appreciation of the contours of the Congress's bow section. We also had some fresh insights that we gleaned from photographs in the Maritime Museum collections. The photos were of Lorenzo Haglund's excavation and removal of a gondola from the bay in 1952. Those photos appear to indicate that the gondola once rested to the Congress's starboard side. With this in mind, we chose to deploy a second transect, in the fashion we had with the first, to the starboard side of the wreck and parallel to the shoreline. From this position and further into the bay, depths receded just a few feet. Arnold and his men had run their vessels as close to shore as possible. We envisioned that the crews had transitioned to the shoreline, much as U.S. Marine artist Colonel Charles Waterhouse did in his depiction of that event. By placing the second transect here, we can investigate the potential of the 1952 excavation being to that side of the Congress, as well as an area where some of the American crews may have come ashore. What we learned might help AMDA instructors determine where best to direct their upcoming survey. Another significant difference from working at Valcour is that Valcour Bay really isn't a bay, it's a strait. The lake's currents run through it, relatively unimpeded. When we initially investigated our targets there, it was a practice to move the uppermost layers of silt away with the sweep of a hand and allow the current to clear our view. We didn't have that luxury at Arnold's Bay. Without any significant current and working in a very shallow water column, any suspended silt wouldn't settle out for a considerable period of time. Fortunately, we found we had a tool that we hadn't had at Valcour. The use of a pinpointer presented a very suitable answer to investigating our targets in the shallows. We already had Garrett brand, model Pro Pointer ATs, on hand for our upcoming participation in the AMDA survey. Those Garrett pinpointers were rated as waterproof to depths of 20 feet. We were working well above that depth along our second transect. The survey then proceeded by a combined use of both the Pulsate X and the pinpointer. The Pulsate X had the range to identify targets, and the pinpointer allowed us to investigate those targets with an almost surgical level of precision. The pinpointer sensitivity is adjusted by the use of one button. A series of audio signals and/or vibrations indicates its level of sensitivity. With a little practice, we found we could adjust the sensitivity regardless of our visibility. The pinpointer would allow us to hone in on our targets, we cause less disturbance to the lake bed during our investigations, and our visibility would be affected to a much lesser degree. We spent several days of protective survey along that transect. A sole investigator would move along the transect with the Pulsate X and pinpointer. They would record the locations of encountered anomalies along the transect, along with the distance to either side of the transect tape. Anomalies would be investigated as they were encountered. Artifacts would be recovered and placed in Ziploc bags with pre-designated tags. That designation would be recorded along with the artifact's locational information on a Mylar clipboard, and the investigator would proceed with their survey. If the investigator's visibility should become greatly diminished, they could make note of their progress and move on to another area where visibility was more workable. Transects are run until no further anomalies are encountered. As the survey continues and we work out in the deeper portions of the bay, we may find we can return to some of the methodologies that we employed at Valcour. But as far as the shallows of Arnold's Bay are concerned, we found these adaptations to be the most productive. Thank you for allowing me the opportunity to share the methodologies that we've been employing in our investigations of these submerged Revolutionary War era battle sites within Lake Champlain. Sherilyn Gilligan, Lake Champlain Maritime Museum's Assistant Director of Archaeology and the project manager for the Arnolds Bay Research Project, will be sharing the results of our 2021 survey season. Thank you.